This video will help you fill out your Ohm's Law lab. But we're actually going to use water balloons to illustrate the relationship between amps, volts, and resistance. It's a great way to illustrate how each one affects each other. It's a way we can physically see the difference in how they interact with each other, as long as everything goes with plan. So here's one example. I'll hold it up here. I have this balloon. I have a taped hole in the center, and then I have it filled. So the resistance is that square hole. So we see this one is 10 ohms. The smaller the hole, the more resistance. Because if I poke a hole in this, the water is going to want to come out, just like the electrons want to move through the circuit. So if I have a small hole, which is a lot of resistance, I should get a little water out, which is small amperage. I can take a bigger balloon, which is more volts, with a bigger hole, so smaller resistance. Bigger the hole, smaller resistance, because a bigger hole will allow more water to come out, because resistance is the opposition to flow. So it's kind of a little backwards, but smaller the hole, higher the resistance. Bigger the hole, lower the resistance for these water balloons. So I have the balloon, the water coming out, and the hole. So which one of those is the resistance? The size of the hole is the resistance. That's how our opposition to flow. And like I said, for our resistance, bigger the hole, smaller the resistance. Usually with the resistor, the bigger the load or the bigger the resistance, the more it opposes the flow. But because we're doing with holes, bigger the hole, lower the resistance, because it's allowing more of that electron or that water to flow through. What is our amperage? The water coming out, which actually moving, is our amperage. So then what is our voltage? Voltage is the force behind it. So the bigger the balloon is, the more force it has behind it. The amperage is how much is moving in the circuit. So that's our water coming out. And then the resistance is that size of the hole. How much are we opposing the flow of electrons? Okay, so for number 4, you're going to hypothesize. If you have 2 balloons filled with the same amount of water, what will happen to the amperage of the 2 balloons if the balloon 1 has twice as much resistance as this balloon number 2? So go ahead and hypothesize as I get this set up. So balloon number 1 has 10 or 12 volts, and it has twice as much resistance as the second balloon. So the purple one's going to be our balloon number 1 with 10 ohms of resistance. So here's our balloon number 1 with 10 volts and 10 ohms of resistance. Our balloon number 2 that has half the resistance is a 12-volt balloon with 5 ohms of resistance. As you can see, the balloons are about the same size, so that's our voltage. The balloons are the same size, so they're both 12 volts. The way we can tell the difference between the ohms is our resistance size. We have a small hole here, smaller the hole, higher the resistance for here, because it's the opposition to flow. So I have 10 ohms here. I have 5 ohms here, twice as big as hole. So if I poke a hole in the one with 10 ohms, we'll watch how much water comes out. Now, if we compare that to one with half the resistance, so what was your hypothesis, correct or incorrect? Go ahead and fill that out and answer number 6. I have two different balloons. So number one has twice the voltage as the second balloon. So number one is 12 volts with 5 ohms of resistance. Balloon number two is 6 volts with 5 ohms of resistance. As we notice, our voltage are different because the two balloons are different sizes. That is our voltage. The size of that balloon is our voltage. So the red balloon, it kind of looks oranges on the camera, is twice as big as the purple balloon. They both, as we see, have the same size hole in the middle. What will happen to the amperage of each balloon? So go ahead and hypothesize about that. Remember, voltage is our size of our balloon. Resistance is the hole. Bigger the hole, the less resistance. So it allows that amperage or our water to come out. Because amperage, the current, is what's actually moving through the circuit. Voltage is what's pushing it through the circuit, and resistance is the opposition to that. So now I'm going to poke each one, and we're going to compare the amperage or the water coming out. Started before 6 and ended after 6. So I say we'd have to kind of look at the amount of water that came out. The trickle was about the same because of the resistance. But let's talk about the amount of water that came out, because that looked kind of close. So 12 had twice the amount of water come out than the 6-volt one. Based on that, and the amount of water coming out is our amperage, was your hypothesis correct or incorrect? Go ahead and write that, and then go ahead and prove it using Ohm's law. So the last one, if you had one balloon twice as much water as the second balloon, so we have twice as much voltage, what would you need to do to the resistance to have the same amperage output? So I have 12 volts with 5 ohms of resistance, 12 volts with 10 ohms of resistance, 6 volts with 5 ohms of resistance, and 6 volts with 10 ohms of resistance. Voltage is how much water is in the balloon. Amperage is how much water comes out of the balloon. Resistance is that hole. Bigger the hole, the lower the resistance. So go ahead and hypothesize what you believe needs to happen so both has the same amount of amperage that comes out. You're going to choose the 4 balloons. We have 12 volts with 5 ohms of resistance, 12 volts with 10 ohms of resistance, 6 volts with 5 ohms of resistance, and 6 volts with 10 ohms. So 10 and 5, 12 and 5, 12 and 10, 6 and 5, 6 and 10. So mathematically, if we do the 12 with 10 ohms of resistance and the 6 with 5, we should have about the same amount of force of water coming out. So if I poke them, they should be about the same. So it wasn't a perfect example, but it kind of highlighted how they had about the same amperage coming out. The last thing you're going to do after you proved it, we kind of talked about that already, about how we can prove that with Ohm's law, that we had the 12 volt with 10 ohms and the 6 volt with 5 ohms. Gave us the same amperage. For the rest of the class, you're going to fill out the reflective part of your lab sheet. After you get done with the analyze part, you're going to fill out the reflection part of it below, number 13, 14, and 15, and then you're going to turn it in. If you have any questions at all, please let me know. I'd be happy to help. Otherwise, congrats on completing this lab.